Risk and return. So risk is part of doing business, and we cannot ignore this. So depending on the type of risk taker you are, risk averse, risk seeker, and risk neutral. Assuming that the higher the risk, the more the return you have. So a risk averse investor is one who avoids risks as much as possible. So any portfolio or investment that they would want to undertake is that which has minimal or no risk at all. Okay, so that is a risk what? A risk averse. A risk seeker is one who follows risk as much as possible. Here the assumption is that the higher the risk, the more the return. Okay, and there's a risk neutral. So the risk appetite may differ from investor to investor. So sometimes when you're asked to ascertain what kind of investor will take on, it's dependent on the risk associated. So now let's go to some of the other important notes that we need to know. So risk can be defined by what we call standard deviation, variance, and coefficient of variation. So in that regard, we'll follow up on the afternoon's session that we had, where we're given associated probabilities and asked to calculate the respective expected returns. So I'll take you slowly. We'll look at an example, then we'll go to the exam question. So risk is important. It is, however, important to calculate our risks. So investors have a rational behavior. They're always seeking more for less. They're putting in less and expecting more. So every investment is assumed to have a probability distribution of returns. So there are several factors that will affect these probabilities. We call them the states of nature. So an industry may have what? Cycles. So these cycles help us understand the performance of businesses. Okay, so we have different cycles. Cycles look like this. Okay, so there are various stages through which a business may undergo. So can somebody tell me what cycles you know from that?
The growth stage, the decline, maturity stage.
Not those ones.
Sorry, do you mind rephrasing your question again?
The business cycles, the natural rise and falls in business activities that we have.
Do you mean
So
the stages like maybe after the initial stage, then maybe there's the growth, and there's the recession, there's the
yes,
boom.
good. A, B, C, D, E. Okay. These are some of the things that I don't want to underrate. What is a boom? What is a normal? What exists in each of these ones? So these are called business cycles. We can explain them in 5 main. So we have what we call the expansion or the recovery phase. So this is the phase within which the business will increase the production at point A. So we're going to point B. So in this phase, what is happening is that employment is increasing, there's consumer spending there, and investment is actually improving. We can simply say the economy is gaining strength or healing. It will reach a point that we call a peak, this point here. So point B is what we call the what? The peak, okay, or the boom. What happens at the boom? Here is the highest point of economic activity, and output and employment is at its maximum, and demand at this point is actually high. So what happens at the boom is that the prices start rising. It's at this point where stock prices are at their highest. All right. So at this point, investors could be advised to actually sell their stock if you are dealing with the stock market just before the prices begin declining. So in that phase, we call this a recession or the contractionary phase. So the economy is constricting, it's going down. In this phase, what is happening? Production is slowing down. Businesses are cutting costs so that they may optimize on production and saving on costs. Unemployment begins to go up, and consumer spending decreases because the disposable income at that stage is reducing. So basically, what is happening is that a recession is taking place. So until we reach a certain point, which we call the trough, D, this is the bottom, right? So this trough, what is happening is the lowest point of the cycle. There's high unemployment, production is at its lowest, also demand, and business failures may increase. Businesses may fall out. But I must also make mention that in these cycles, there are certain businesses that thrive regardless. We have the pharmaceutical, people get sick. The wars, they don't are not susceptible to such business cycles. So even as you're investing, you need to also know at the point that there are certain businesses that never suffer from these cycles. At the trough, when it prolongs for more than a year, we now call it a depression. So a depression, well, everything has a revival stage. Then again, we go back to the recovery stage where the business starts expanding. Investment starts increasing, jobs are slowly being created, and consumer confidence what increases and demand rises. So these are the cycles that you see here. And they talk about the boom, and this you need to have an idea of what we are talking about. Are we together? Any questions?
Yes, we are.
And so now I want us to see how to calculate the expected returns for the particular stocks A and B. What I'll do on A is what you do on B. So in our earlier example, we were not given associated probabilities. And now the way I'll do this question is the way I expect you to do question B as your homework. Is that clear? So I make sure to say the higher the expected return, the better the stock. But the higher the variance of standard deviation, the more risky the stock you have. So you're going to base your reasoning as to whether investment must take place depending on the type of investor. Sometimes, even with high risk, risk seeker may decide to invest in such a stock. So expected return can be in percentage. We talked about three kinds of returns. There's expected return, realized return, and what? Okay, so you can use a tabular form to calculate these returns. So now, anyone take us through how to calculate the expected return for asset A? Yes, Melissa?
So you sum up all the entries under the return of stock A.
So you sum up all the returns on A and do what?
You divide by 3 in this case, based off the number of states of the economy.
Okay, yeah. Now, this is what I wanted to explain. This is on the assumption that you're not given probabilities, but these probabilities that are given here, what you're calculating is actually the average return, not the expected return. So if I didn't extend
So
this, at least
isn't
you'd make
the Collins, isn't the expected returns
Uh-huh.
RI multiplied by PI?
Good.
So the probability multiplied by the returns.
Great. So for asset A, what is expected return? The return of probability is 0.3 times what? And 5%.
0.5
Plus 0.4 times what?
times 15.
It's 15%. And
0.3
0.3
plus 0.3 times negative 10%.
negative 10%. Correct. So what do we get? So that is how we find the expected return. So quickly find the expected return with the same formula for investment B. So calculate that. I'm giving you 2 minutes. What have you gotten?
$10.5.
Okay. 10.5. That is for stock A.
For stock A.
Yes. So how did you find it? Just initial computation. So you multiply this by that, you get this. This by that, we get this. This by that, we get that. The total is our expected return. So you do the same for asset B. All right.
So for the other stock, I've
So for
gotten
asset B, what have you found?
4.9%.
Pardon?
4.9%.
4.9%. Let's see if that is correct. Asset B. Okay. Is that what the others found? 12.9, yes, percent. That's correct. Okay, so for asset A, 10.5 is correct. So what else do we do? How do we calculate the standard deviation? Are we together on how we calculated the expected return for asset A? How do we calculate the variance?
The variance should be R minus ER.
Okay, so after getting this is the return in A, in the ER there. And we start now the return on A minus the ER. Okay, so subtract 25% minus 10.5, and we square it. RA minus ER squared. Then you multiply by the probability. Okay, P times RA minus ER power 2. Okay, so what is 25% minus 10.5? What do we get?
0.145. Do we have to
Just as
convert
percentages, the way they are.
it?
Don't
Oh,
put,
okay.
huh?
Convert it.
14.5
14.5. Then we square it. What do we get?
to 10
To 10.
to 10.25.
To 10 into 5. Then you multiply it by the probability. What's the probability? 0.3. What do we get?
63.075.
63.0,
0.075.
not square root.
Se-
Oh, you multiply this by 0.3, 63.0.
You've written 73, 63.0.
Okay. 63.075. Yes. Somebody else to lead us through here. Mm-hmm. Yeah.
You mean the normal, under normal state of economy?
Yes. So 15 minus what?
Okay, so that would be 15 minus, sorry, let me start my calculator. That's 15 minus 10.5,
Mm-hmm.
which is 4.5.
Uh-huh.
Okay, then square you square that,
Mm-hmm.
which is 20.25.
Mm-hmm. Mm-hmm.
Okay, then you multiply that by the probability,
Mm-hmm.
which is 0.4,
Mm-hmm.
which gives us 8.1.
8.1. Okay.
Yeah.
Then minus 10 minus 10.5.
Minus 10 minus 10.5, which is minus 20.5.
Mm-hmm. And you square
Then
it.
square that, it gives you 420.25.
Mm-hmm.
Okay, 420.25, you multiply that by the probability of 0.3, giving you 126.075.
Okay, then you total up here, get the variance, then use square root. So add them up.
Okay, the total of those is 197.25.
197.25. And you square root it.
You square root it. It's 14.04 if it's 2 decimal places. Or do you want the full figure?
0.04. And the CV is when you divide the standard deviation over expected return. Okay, what are you getting?
Okay, it's 14.04. Our expected return was 10.5, right?
Yes.
10.5, which is 1.34.
1.335, 1.34, correct? So 1.34. Correct. So are we together so far? So those who just joined, how did you find the expected return? We simply multiply the respective probabilities times what? The returns, and we sum them up. Okay. How do you find the variance? We subtracted from each of them the expected return, and we squared and multiplied by the probability and totaled up. The total is called the variance. The square root is the standard deviation. To find the CV, which is a risk per unit, what did we do? We divided by the what? we divide it by the expected return. So far all together?
Yeah, on my end.
Right. So remember we found our expected return for asset A as 12.5. So second question is asking us to find the portfolio expected return if we are told that each asset held what? It held 50%. So meaning the expected portfolio is the weight of asset A times its expected return times the weight of asset B times expected return. So in this case, the weight was what? Was 50-50. So we put 50 on what? The 10.5 plus 0.5 on the 12.9. So the portfolio expected return is 11.7. Suppose they asked us that we invested 40% in asset A without telling us how much was weighted in asset B. So we'd have put 0.4 on 10.5. And what do we put here? 0.6, because the total must add up to 100. Is that clear? Okay. So now we go to calculating what we call the covariance. The covariance. Now the covariance is simply calculated as follows. Remember this column we had where there are negatives, where we have expected return of individual A minus this, we're finding what? 14.5. And here we're finding 4.5. So we're going to multiply 0.3 times 14.5 times this column that you're going to produce as you're producing asset B. The return on asset B minus expected return for asset B. It will give you a column like this one here. So the answer that you're going to get, you will multiply them as follows. So we're going to pick only three values. This one times the value for asset B in this column, plus this one times the asset B column. I don't know whether we are together. So this is what we're looking at here. This is called the covariance. So the covariance will be calculated 0.3 times what? 14.5 times 6.1. We go to the next 0.4 times 4.5 times 0.9 plus 0.3 times negative 20.5 times 4.9. So where are these figures coming from? These figures are coming from the assumption that we already calculated. This was our asset what? Asset A. What were the figures for asset B? Asset B, the figures were what? The returns. Go here in the table, original table, there's 19, 12, 8. 19, 12, 8. So 19, 12, 8. So remember that the expected return for asset B was what? 12.9. Are we together? So that was our expected return for asset what? Asset B. So subtract the expected return for each of these ones here. So what is 19 minus 12.9? What are we getting? 19 minus 12.9?
6.1.
6.1, right? So we put our 6.1 here. Okay. So I'm just trying to modify this column. So if this was asset what? B. Okay. So suppose this was a set B. So here this was 6.1. What is 12 minus 12.9? This is 0.9 negative, right? 8 minus
Negative
0.9. 8 minus 0.
negative.
Negative 4.9, right? So the covariance now would that be, we'll multiply this times what? Times this. Again, this times that. Lastly, this times that. So this is what is actually being shown in the pamphlet. So when you multiply 0.3, 4.9619 plus 0.4, 4.5 plus that, so what we're going to get is actually a covariance, which is what? 55% or 0.55. So this shows that there's a positive relationship between A and B. Is that clear? Elisa, are we together?
Sorry. So when you got your covariance of 55.05, you have indicated to say it shows how exactly, sorry, do you
You
get
can
to
either get a
tell if there's
negative or a positive. So if the answer is
okay, so
positive,
if it's
it
a
means that they are positive related. If it's a negative,
positive, really,
get it.
okay.
It's just a sign we're looking at.
All right. Thank you. That's well noted.
Okay. Then we go to what we call the portfolio variance.
Collins, maybe before we move on, maybe
Uh-huh.
I'm not writing them properly. Is it possible that you can just there on the whiteboard where you write, just write even just for A, then so that it's easy for
So
me to
covariance,
follow.
therefore,
We're
for the
doing
assets.
covariance for each stock, like
No,
covariance for
they
A
go together.
alone,
It's covariance
covariance.
A, B. Okay?
Okay.
Asset A and asset B. So it's 0.3 times what? 14.5 times what? 6.1 plus. Can somebody tell me? Next, we're going to multiply 0.4 times what? 4.5 times what? Negative 0.9.
That is 0.9.
And then lastly, plus 0.3.
That's 0.3
Mhm.
times minus 20.5
Uh-huh.
times negative 4.9.
Uh-huh. Okay. So when you multiply all these, what you're going to get is 0.55, which is the same as what? 55%. So what we're interested in is the sign, and we can tell that these are positively related. All right.
Colin, I
Yes,
have
sir.
a question.
Uh-huh.
When you're finding the variance, why were we using the summation of expected return? Why were we not like saying like why we are 14.5
On the variance or covariance?
on the variance?
Here, on the standard deviation and variance here.
Yes, we're using 14.5 throughout. Why were we not using the
Because the
expected
expected
value for
return,
expected?
no, we're using 10.5 throughout. We're subtracting from each return, we subtract 10.5, 10.5, 10.5. All right? Then the answer we get,
So
we
my
square
question,
it.
why were we not using the expected return for each what do you call that? For each row?
For each
Was it show
asset,
at the
no, the expected
yes?
return is for the entire portfolio, it's for the entire project. There's no expected return for each row. Remember, what we did
And
during the day was the average. Here, how did you find
now
the
if you go
expected?
back, if we go back to here, because we found the error for each row, we have
No, not for each row.
7.56%.
So what we're dealing with asset A. By the way, I just put asset B just now. Initially, we had asset A only.
No, I'm
Okay?
talking about where you have error, the last column, where you have
Uh-huh.
7.56%,
No,
negative
this is not
3%.
ERR. It's just for each individual. The actual ERR is this one here that we're using. So this is what you subtract from
Oh,
each of them. This is the
okay.
average for each of them after we add. Very good question. I didn't see it like that. You're not subtracting each, you're subtracting this figure. overall.
Okay, from
It's
the
ER.
overall ER.
Yes.
Okay. Okay.
Right, so having done that, we go to what? Our portfolio variance and standard deviation. So we are told in here to say, suppose we want to hold 50% funds to be invested in each half. So A has 50%, B has 50% respectively. So they have spoon-fed you that A had 10.5, this had 12.9. So now we use this formula to find the standard deviation variance. So weight of A was 50%, and the variance of A was what? What was the variance for A? It was, it was 192, 196.25. So if you're using standard deviation is 14, you square the 14. So here, 0.5 times 14 squared plus the weight for B was 50% of 0.5, then times the standard deviation for B was 0.04, which you're supposed to do as your homework. All right, then plus 2, the weight of A 50%, weight of B is 50%. Then the covariance we found was 0.55. So this entire calculation is what gives us what? Our standard deviation. This is called the portfolio standard deviation. It's one of the trickiest to find. So it's within +1, -1. So when it's 0, it means there's no correlation. When you get a positive, it means what? Positively correlated. So this is our portfolio standard deviation, right? So I think now we are good to go to answer this question. Compute the coefficient of correlation. Who remembers what is the formula for coefficient of correlation? So coefficient of correlation, this is a covariance. Coefficient of correlation is when we do what? We divide the correlation over the standard deviation for each of them. I didn't show it in here. Okay. So the covariance of both of them you divide by the standard deviation for each. That is how you find the coefficient of correlation. And also lastly, the question is asking us to find the portfolio standard deviation, which I have done there. So I want you to redo this question as your homework because to help me assess how you understood this. I've explained quite a lot of things here. So please redo this and send it to me. This is the toughest you can ever have. I also made mention to say if you're not given the probabilities, the assumption is that there is equal probability. So here, if there were 4 states of nature, we would have divided by 4. So they have 0.25. There are 3, it's 1/3. So we divide by the number of states of nature that you have. So please redo this homework. Once you get the answer correct, I'll send you the video. Thank you so much for your time. We end here.